Well guys, you join me in the lab today and we're playing around with the Raspberry Pi and the Roberts radio. Come on, focus. And it should be fun, hopefully, but I'm coming to you with a problem rather than I am solutions. So I've been trying to read capacitance with the Raspberry Pi. Now the problem with that is I can read some capacitances, so I can read big old capacitors like this, what is that, 100 UF, and I can read this 10 UF one, but going down to smaller ones like this tiny little 22 picofarad one, not so easy it turns out. So on the screen here, I'm not sure if it's going to focus on that or not, but you'll be able to see over here we've got some readings coming out of my Raspberry Pi. Now I've disconnected it now, but these are the last readings I got. Now these are measurements in nanoseconds, and what I'm doing is using an RC timer circuit. So it's charging up that capacitor and waiting to see when it gets a high on one of the digital input pins. Now a high in Raspberry Pi terms is something around 2.2 volts, I think, might be 2 volts. But it's giving me a value, and that's all I need. I don't need the specific capacitance. It's for this Roberts radio, we've got this tuning dial here, and that's a variable capacitor. Now, that's brilliant. It means that I can read it, but this thing is in the picofarad range, so it's pretty low. So I tried again with an Arduino. Let's see if I can get that visible, maybe. It's a bit blurry. Still, I can read down to nanofarads with that. I picked up an example sketch off the interwebs, and it will read down to nanofarads, and that's a limitation of the time that you can read on here. So we can look at milliseconds and microseconds, but not the range that I need to go down to. So we're going to do something else. So I've got myself a little Nano here. This is a Nano 328. And what I'm going to do is I'm going to create a 555 timer circuit and use the capacitor to vary the frequency. And that way I'll be able to read that frequency on my Arduino. I might be able to do it on the Raspberry Pi, but I'm going to read it on the Arduino and then kick that out of a serial to the Raspberry Pi. And so that frequency should change by a larger degree and be more regular than the time I'm getting on here. The problem with the Raspberry Pi and reading capacitance is that when you're running code on the Raspberry Pi, it's not just running your code like an Arduino would just be running your code. The Raspberry Pi is running an entire OS, and when it's playing a radio station, it's got a lot more overhead when it's streaming things from the internet and processing the MP3 into a PCM value. So it's difficult, but I have got it working. So I'm no longer using the OMX player. I'm now using the VLC to do that instead. So it does work. The radio cube is behind all this junk right now. This is working perfectly now, so I'm very happy with that. I just need to turn the LDR bits into little breakout boards and glue them into the 3D printed case. Of course, it's not going to be a permanent feature. It is, it's only a toy. So that will probably come out of there at some point. It's the only Raspberry Pi A+ that I have, and I might use it for here because it's lower power than the B+, which is nice. Okay, well that's all for now. I will update you once I have some more information on focus. It's not going to, is it? There we go. On the 555 timer circuit that I'm going to use, and hopefully we'll get some frequency values out that that mean a bit more than these figures up here, because the ones that I'm getting from the Raspberry Pi at the moment, they vary too greatly. So it's only giving me an essential resolution of 3. So I can get 3 stations across this whole range here. So I can place the pin around here, here, and here, and it gives me 3 definitive values that don't vary too much. The hysteresis zone in these areas is huge, so it can report a value of 1,330. That's just the difference in time. In nanoseconds that changes between the charging. It can report 1330, and then 5 seconds later the next value that comes out will be 1.5 something, because the process has taken some time to do something else and it hasn't gotten around to performing that instruction. And we're talking about tiny differences in time, but it has a big effect on how I'm trying to read this. And I want to do that because I don't want to take out all of this stuff in the back here. I'd like to keep most of it if I can. So this is our little timing, our little variable capacitor I'm hooked onto at the moment. I'd like to keep that in there, and also these gang switches as well to tell the Pi to shut down. I think that's what we'll do. And I've got the volume control in there too. And I'm not going to remove the speaker either. And I might leave this leave this carbon rod in there too. Anyway, that's it for now.